Hey, welcome back to my channel. And today we're going to do some math problems. So let's go. So today we will be getting into 3.4, which is called Water Wonderland. And what we're going to be able to do today is interpret the graphs and equations of functions. So again, interpret is something that your computer can't do for you. It can give you facts and then you can do some interpreting, but your computer can't do it. So this is how we are markedly making you better, okay? Write equations for the graphs of functions. This is something you already know how to do, so that's not new. Combine two linear functions, which means you're instead of one function, two functions or two parts of functions are going to make up one function, right? So how does function notation connect to a graph? Function notation. What connections can be made with function notation and a story context, meaning a word problem? And how do I combine functions graphically and algebraically? Okay. So here's our goal. If you can get to some of this, awesome. If you can get to most of this, even better. If you can get one of these things, that is a good thing. Okay. Your goal is to make sure you understand more and more every day. All right. So here's your context. Allie and Dane, I think that's how you pronounce their names. So there you go. Work at a water park and are required to drain the water at the end of each month for the ride they supervise. Each uses a pump to remove the water from the small pool at the bottom of their ride. The graph given represents the amount of water in Allie's pool, A of X, and Dane's pool, D of X, over time. Make as many observations as possible with the information from the graph. All right. So can you share some of the observations you guys made? The red line decreases. One line is steeper. I like this. Man, you guys went through a lot. The amount of water in Allie's pool crosses with the amount of water in Dane's pool. Is that true? The amount of water in Allie. Oh yeah, look, they cross. You're right. Someone said they intersect. Very good. Someone says the blue line increases. I wouldn't say that, right? Because look, it's going down, 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 right? So remember, decreases means that if this is a roller coaster track from left to right, it's going down. So I would agree. They both decrease. The red line started higher on the y-axis. Is that true? Oh, I wonder what that means in terms of that context. Okay, they reach equal levels at one point. Oh, yeah. That's where they intersect. I agree with that. When you say blue increases more than the red line, I don't think you mean increases. I think you mean, yeah. There's a better way to say what you're saying. I understand, but I'm not going to say it. Sorry. Good teachers make your students say it. You're welcome. You're welcome. Allie's is going down straighter. So when you say Allie's is going down straighter, I know what you mean, but I think you can say that a little differently. If you talk about the context of what's happening here, I understand. So Allie's has more water and crosses with Dane's. Good. The amount of time is bigger for Dane's pool. Yeah. It takes, I think this person is saying it takes Dane's pool longer to drain. It took me a while to say that. It takes Dane's pool longer to drain. Ooh, someone said the red line drains faster than the blue line. How can that person tell that? I don't know. How do they know that the red, wait, who's red? How do you know that Allie's pool drains faster? I wonder how, oh, because it's steeper. Yes, very good. Because Allie's line is steeper, then that means that her pool is draining faster. Wow, you guys are like pros at this. It says, oh, it's a slower draining process. Very good. Yeah, maybe there's more stuff clogged in Dane's pool. I don't know. Maybe Dane's pump is older. I don't know. So blue finished at a slower pace. I agree with that. So Dane's pool drained slower. Yes, blue line. Okay, I agree with this. Let's see. Someone put cheese in the chat, meaning slope. That's just gonna stay with us for a long time, huh? It takes because the red line hits the bottom before the blue line. So the red line hits the bottom. What does he mean by the bottom? I know what he means, but I'm gonna make you say it. So what does he mean by it takes because the red line hits the bottom before the blue line? What do you think he means? Okay, someone said Dane had less water to start. Very good. Ooh, so this person says Dane had less water to start, but took longer than Allie's to drain. Do you agree that Dane's took longer to start? Do you see that? Do you see that in this picture right here? Do you see how Dane had less water? Everyone's like, oh yeah, I see it, because it had a lower y-intercept, right? And then it took him longer because when Allie's was already drained, Dane's is still going. Very good. That's a strong observation. Yes, very good. So when we said bottom earlier, the person who said it reaches the bottom, they were talking about the x-axis. Very good. Someone said the red line hits the x-axis before the blue one. Very good. And Dane probably had a smaller pump. Exactly. Smaller pump, slower pump. I don't know. Maybe something was clogged in the pump. I don't know. Something happened there. I am really impressed with how much you all just said. So I'm just going to say two things. The quantity of observations, I am so impressed with. I now have to give everybody extra credit because of that. But Ms. Johnson, everybody didn't participate. Yeah, but when I get that much content, I have to give everybody extra credit. Number two, not only the quantity of it, but do you understand what I mean by the quality of responses? Free cheese, Jesus. Okay, sorry. The quality of responses. Do you understand what I mean by the quality of responses? Yes, you observed, and your observations went back and forth between the context and just the graph and just the graph and context. So when you give me stuff like this, I have no doubt what's about to happen on the test. How, not why. Yeah, you guys asked, or not asked, you answered deeper questions. For example, some of you asked and answered why one, or how. The how questions are good too. How and why questions are very, very strong. The lower end, not lower, I don't want to use the word lower, I want to use the word more accessible questions that like are more easier to answer. I don't like the word easy. I'll think about another word, but those questions are things that are low-hanging fruit, meaning most people can answer that. You guys were answering questions and making connections that were much stronger. Okay. So when you do work like that, to me, I'm like, oh, I already know what's going to happen on the test. You guys are going to rock it. Okay. All right, let's move on. So write the equation to represent the draining of Dane's pool, d of x. What does each part of the equation mean? So Dane figured out that the pump he uses drains water at a rate of 1,000 gallons per minute and takes 24 minutes to drain. So I wanted to peek at your answer here. So only a couple people got it. So we definitely need to work on this part. So I'm going to show you on my, not on that, I'm going to show you here. So you guys did such a good job explaining this. Keep those observations key. People think, man, Ms. Johnson, observations are not that big of a deal. Yes, they are. Okay. So if you don't believe that observations are a big deal, it kind of goes like this. If you didn't notice that the blue one was draining slower than the red one, when you write the equations of the lines, you have no context, right? Okay, very good. So some people got a little stuck here. So let's just talk about this one. It says Dane figured out that the pump he uses drains water at a rate of 1,000 gallons per minute, and it takes 24 minutes to drain. write the equation to represent the, so write the draining of Dane's pool. What does each part of the equation mean? Okay, so let's go back up here. So I cannot show you both of these things. Okay, so what is 1,000 gallons per minute? And where does 24 minutes belong on our graph right now? Where does 1,000 gallons per minute and 24 minutes belong on our graph? Anybody see anything here? Someone says, I think 1,000 is the slope. Let me see. 1,000 gallons per minute. How many of you agree with that person? Someone said, I think 1,000 is a slope. 1,000 is slope. Can I get some yeses? No, I don't know. I'm not sure. I need to put extra credit at the top or else I'm going to forget. Hold on. What do you guys think? Is 1,000 the slope? 1,000 is the slope. Ms. Johnson, how do you know 1,000 is a slope? Because that's telling you how many gallons per minute. Slope is always rise over run. Rise over run. If you look over here, this is rise, gallons, run is your minutes. So yes, it is true. So this is my slope. Okay, so this is going to be my slope. Okay, so that gives me part of my equation. Okay, so if you're thinking, oh, Ms. Johnson, I know this is y equals mx plus b kind of thing. Okay, great. If you don't like that one, then you can also use that other one. Remember, y equals m parentheses x minus x1 plus y1. Remember, we learned that one last chapter, right? So you can use this. I would call this the point slope, right? This is point slope formula. This is slope intercept formula. Okay, so m is 1,000. Okay, I can kind of write it on there. I can kind of see it. I will say, because it's draining, would you understand if I wrote, that's why m equals negative 1,000? So for those of you who said, yes, he's right, and those of you who said, no, he's wrong, both of you were actually right. Ms. Johnson, how could we both be right? Because 1,000 refers to the slope, but mathematically, when we're talking about it, we have to put negative. Does everybody see why I have to put negative? Yeah, plus look at your graph. That's a negative slope, isn't it? Because he's going down, down, down. Okay. All right. What about this 24 business? What about this 24 business? What do I do with that? Yeah, it's decreasing. Exactly. What do I do with this 24? Yeah, someone said it earlier. It's the intercept. But which one? Is it the y-intercept right here? Or is it your x-intercept over here? Yeah, it's your x-intercept, not your y-intercept. Now think about it. This says 24 what? Everyone read it. Say it together. 24, say it out loud. Minutes. Minutes. So where would I put it? Would I put it on the gallons axis or the minutes axis? Oh, of course, Miss Johnson. Yeah. So Miss Johnson's, if you don't know, Miss Johnson's favorite math practice is called attend to precision. Okay. What it means is I say what I mean, and when I say it, you understand what I mean. It also means paying attention to the details, like it's giving you minutes here. They're screaming at you, I'm a minutes number, not a gallons number, right? This is not a gallons number. This is a gallons per minute number, right? So because they told you it's a minutes number, they said it takes 24 minutes to drain. So Ms. Johnson, why is that 24 right there? Why is that 24? Because after 24 minutes, how much water is in my pool, or Dane's pool rather? How much water is in the pool after 24 minutes? None. Very good, right? Because it takes 24 minutes to drain. So at 24, I should have 0 gallons. 0 gallons. Is everybody okay with this? Someone said, would the y-intercept be 1,000? And the answer is no. I understand why you want to put it there, but the answer is no. So, Ms. Johnson, so you have an x-intercept, right? And I have my slope. Isn't that enough to build my equation? Yes. Okay. It's not. Which one would you use? Would you use this one? Or would you use this one? Would you use slope intercepts? Would you use slope intercepts? Or would you use point slope? So SI or PS, slope intercept or point slope? Which one would you use? Slope intercept or point slope? Remember, this is the whole reason why we even call slope our cheese, by the way, because of this guy right here. You guys didn't remember. You guys remember that cheese is called our slope for some reason. I'll tell you why again. Okay, yes, we use point slope. Okay, the reason why we're using point slope is what do you have? Do you have the slope? Yes. Okay, Ms. Johnson, but both of those equations have slope. Good. Here, what does B mean again? What does B mean? What does B mean? What does B represent? Yeah, it's the y-intercept. Did they give you the y-intercept? Look, did they give you the y-intercept? No. So here you are wanting a cheeseburger and you have no cheese. Oh, no, wait, we have cheese. I'm so sorry. You have no burger. You have no burger. For some reason, you guys all call cheese. I know why though. Yeah. You want a cheeseburger, but you have no burger. So no, I'm not building you a cheeseburger with no burger. Okay. Over here, do we have everything that we need? Do we have the point? Yes, we have this point right here. Do we have the slope? Everyone's like, yes, it's right here. Okay, because we have both of those, can everybody right now do your best? Plug in as much as you know, plug it in. Okay, I'm going to give you like 20 seconds. 20 seconds. All right, so you all plugged it in and I saw some of your answers. Very fancy work. Okay, in case you didn't know, if 24 is my, what is 24? Is 24 my X? Or my Y? Is 24 my X? Or, oh, it is my X because it's my x-intercept. Okay, so here's my 2 ingredient. Some of you guys were calling it, you guys were talking about quesadillas in the chat while we were waiting. So yes, you can make a quesadilla. All you need is 2 ingredients. Your first ingredient is the point. So the point is 24 comma, what's my Y? If 24 is my X, what's my Y? If 24 is my X, what is my Y? If 24 is my X, what's my Y? Nope, it's not 1,000. Look, 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 look. It's right here. Yes, it's 0. It has to be 0. Ms. Johnson, why does it have to be 0? You should come up with at least 2 reasons why this has to be 0. At least 2 reasons. Someone says, Ms. Johnson, it has to be 0 because why? Someone say it. Yeah, it's on the graph 24, 0. That's one reason. Someone else says it's the x-intercept. And x-intercept means y equals to 0. Good. Third reason, go back to the context. What is happening at this point, y'all? What's happening at that point? Yeah, it's empty, meaning 0 gallons of water, hence 24 comma 0. If you did not know the 0 goes right here, put that in your brain right now. That way it doesn't get you on the quiz or the test. Okay, good. The 2 ingredient quesadilla, you need your tortilla and you need cheese. Where's my cheese? Where's my slope? I'm just assuming that everybody's house has butter or some kind of oil. Yes, slope is, but make sure you put negative 1,000. Remember, you guys all told me, yes, Ms. Johnson, I understand why it's negative 1,000. So here's your 2 ingredient quesadilla. Ready? Take all these pieces and plug them in like this. Y is Y. Equals is equals. M is negative 1,000. Parentheses is parentheses. X is X, minus is minus, X1. Miss Johnson, You didn't tell me what x1 is. Where's my x1? What's x? Yes, it's 24. In case you didn't know, this is x1. This is y1. Okay. Ms. Johnson, isn't that technically 3 ingredients? No, because it's a point and a slope. So it should say x minus 24, parentheses. Oops, I forgot. Parentheses should be parentheses. Plus is still plus. And then y1 is 0. Ms. Johnson, do I have to put plus 0? No, you can clean it up. Clean it up. So y equals negative 1000 parentheses x minus 24. If you don't want the 0 there, don't put it there. I tend to leave it there to remind my brain that this is a point, 24 comma 0. And my slope, my 2 ingredient quesadilla. Everybody okay with this? Questions on this? Yes. Okay, good. If you didn't know something, if you didn't know how to tell, like if you were like lost on the if you were lost on the human who said, Miss Johnson, this is my slope, learn it. Why is it a straight line on Desmos? Okay, ironically, I'm gonna tease you all right now. All lines are straight. Promise. All lines are straight. I do know what you're talking about though. Hold on. Let's write this in here. So if we write this equation in here, we write y equals negative 1000, move cursor please, parentheses x minus 24, close parentheses. Everybody okay with this? Someone said, why is it a straight line? Yes, I know. I do know what you mean. This person said a straight line, but he actually meant a vertical line. And anybody know why this looks like a vertical line? I'm going to hence put on the what's the right word I want to use? I want to emphasize looks like. Yeah, super steep, right? Looks like. So if I changed my, and this is what, you know, I will show you something that news people or people who are trying to sway your opinion do all the time. They change your axes. So let's say we go from -1, I don't know, to 25. Okay. And let's change my X values from, I don't know, let's do -1 to, I don't know, 500, maybe 50. Is that good? No, 40, 10. No, let's do 100 maybe. Is that going to be good in there? Hold on. Still looks, but you can kind of see the slope there, can't you? Yeah. Yeah, it's truly very steep. But if you think about it, 1,000 gallons per minute, that's really fast, right? What type of cheese do we use? Slope cheese. Slope cheese is the cheese that we use. These are hilarious. Okay, any questions on this? Miss Johnson, but I love slope intercept. Couldn't I use it to find slope intercept? Absolutely. You would use these points as your X and your Y. You would plug it in, and then you would find your B. But for me, I just, whatever they give me, that's what I make. Every now and then, when we have food in our refrigerator that we know we need to eat very soon, we play this game of like, what can we make with all this food? Sometimes it comes out really great. Sometimes not so good. Okay, very good. Based on this information, correctly label the graph shown, which we did. I kind of want to know what the y-intercept is. I want to know the y-intercept. Oh my gosh, you guys are talking about cheese right now. Okay, looking at my picture here, come back, let go of the cheese for 2 seconds. Thank you. So, hey, how would I find out what my slope, my intercept is, my y-intercept? How would I find my y-intercept looking at this? Okay, come back to me. Come back. How do I find, thank you. How do I find my y-intercept? Looking at this picture, how do I find my y-intercept? Come on, y'all. Miss Johnson, y equals, anybody see it? Equals, nope. -1,000, -1,000, parentheses. Hey, Miss Johnson, this one doesn't have parentheses. Anybody know what they could do right here? Anybody know what they could do right here? Okay, wait, can we pause really quick? Our y-intercept cannot be negative 1,000 because that doesn't make sense in our story nor our graph. Does this look like negative 1,000? Yeah, no. Okay, if you said, so this is, okay, again, remember my y math? So let's see. If you say that my y-intercept is negative 1,000, what does that mean for Dane? Dang. Yes, Miss Dana. Can you put that to the public chat, please? Can you please put that to the public chat? Oh my goodness gracious. Oh my goodness gracious. I'm going to snip it because it needs to go in my notebook. Sorry. Wait, what are we doing here, people? Here we go. New. You're going to put that to the public chat, right, Miss Dana? Oh, all right. Thank you. Copy. Very good. Very good. Here is what our friend said. Check this out. She says, since 1,000 gallons were gone every minute, and no, that's perfect. And it took 24 minutes. Doesn't that mean the y-intercept started at 24,000? Okay, everyone, can we just all just take a second? And number one, she's right, okay? But this is a completely different way of thinking about it. So can everybody just think about that for just a second? Just, okay, make sense of it. Like actively make sense of this. Okay, so that's one way. This is the correct answer. So right now, I'm going to go up here to my graph. You should too, and label it 24,000. Ms. Johnson, that's a lot of gallons of water. Yeah, I know. And we're in California, right? So that's a lot of water. You're right. Okay. So the other way that I want to make you consider looking at it is this. Look, what do you do right here? What do you do? What can you do right here? Anybody see anything that you could do? Hint, hint, math. Hint, hint. What would you do? What could you do right there? I know. You should put that to the public, hun. Switch to, yeah, I want to convert this to slope intercept. So what would you do right here? What would you do right here? I understood you. Anybody notice this? Sometimes your teacher would do this thing. Your teacher would go like, and then you're going to do this. You guys remember this? Yeah, no parentheses, distribute it. Okay, pause really quick. Everyone right now, distribute this right now. Go right now, distribute. So in case you forgot how to distribute, you're just multiplying negative 1,000 times x, which is just negative 1,000x. Oops, I missed a 0. And then what's negative 1,000 times negative 24? Very good. It's positive. Wait a second. Didn't someone already tell us about 24,000? Didn't someone already tell us this? Did someone already tell us this? No. Yes. Yes. Look, this one is this one. But Miss Johnson, how did she know? She didn't even do this. But she just made sense of it, right? So that 24,000 is that 24,000 and that 24. Miss Johnson, is that 24,000 because of that 24? Yes. Right? Okay, here we go. It says, let's see, what does each part of the equation mean? So I should be able to point to something negative 1,000, and you should be able to tell me what that means in the context of them draining the pool. Why is negative 1,000 there? Someone says something quick. Yikes, I gotta go. Sorry. It is the slope. Very good. Why is 24,000 there? And someone says that's how much water they started with. right? Someone says, but Miss Johnson, why is this one 24? Because that's how long it took the pool to drain. Okay, so it says, based on this information, correctly label the graph, we did. What values of X make sense in this situation? Write the domain of the function that represents the amount of water in Dane's pool. What? Domain. Give me domain here, people. Yeah, it's our features. Very good. Yes, there are plenty, right? There's a max, there's a min, there's a lot of things. So looking at my domain, someone tell me about my domain. Yes, very good. Someone already put it. Let me see. Looking at this right here, do you guys think I should use brackets or parentheses? Brackets or parentheses? Yeah, it's brackets. It's brackets because 0 and 24 are included. It's brackets because 0 minutes was how much they started, at what time they started, 0 minutes. That's when they hit the, the stopwatch. And 24 minutes is when they stopped the stopwatch because that's when the pool was completely drained. Very good. It says I'm going to finish right now. What output values make sense in this situation? Write the range of the function. Range, write the range. What's the range? Oh, range. You guys are so into food right now. It's so funny. What's the range? From what to what? The other way. It's just the other way. Very good. What's the lowest Y value? Start at the bottom. Yeah. What's the lowest Y value? Yeah. Range is our output. Very good. Very good connection. So the lowest Y value for our blue function is what number? Lowest. I only got one person who has this answer. Yeah, the lowest is 0, not 24. 24 is our X number. When we're talking about our range, we're only looking at our Y numbers. So our lowest number is 0. Very good. Very good. I got 2 people on it. And what's the highest? Oh, you said 0 in your head. I love it. And what's your highest number? What's the highest that you can get? What's the highest blue number? 24,000. Perfect. Very good. So it goes from 0 to 24,000. Someone in the chat put, oh, I don't like this comma. I'm going to show you, Miss Johnson. Why didn't you put a comma right there? Why did you erase your comma? Because commas mean from this to this, and I don't want anybody to think from 0 to 24 to 0. That doesn't make sense. Yeah, so no commas in there. Someone put 24,000 comma 0, and I don't want you to do that because whenever we write numbers, we always write numbers in order from small to large. Okay, write the equation there. Okay, so this is what I'm going to have you guys pause. I'm going to have you guys start on Allie's equation for tonight's homework, okay? Thank you so much. Give me a second. Let me stop this video.